So just one announcement before we get started, before I introduce the speaker. Next month, on March 28th, will be our monthly lecture. And the speaker then will be Neil Farber. He's a NASA ambassador, and the title of his talk is going to be on astrobiology, the search for life in the universe. So today we're going into our deepest sense of self, and next month we're going to go out into outer space. So mark that date, March 28th. So we're fortunate today to have our speaker, Pham. So Tom is an SDIS member, and he's a professional computer programmer by training. He's worked for a number of big and small companies, IBM Core being one of them. But he's also a Renaissance man. He's very interested in philosophy and independent study, and this is what he's going to talk to us about. This presentation arose from an online discussion group that he participates in, where they discuss Aristotle. And they're going through, I guess, all of the books that Aristotle wrote. I think they're called the Organon. Yeah, they're like 5 or 6 books. And today he's going to talk about one specific one, which deals with reasoning and how it develops from question and answer. So thank you, Tom, and welcome.
Thank you, Jamie. Welcome. Hello, everybody. Can you all hear me? Can people on Zoom hear me?
Tom, can you speak?
Okay. I will try to speak up because there's an event going on outdoors to celebrate Lunar New Year, the Chinese and Orientals. My presentation today is, you saw on the description, does objective thinking require math logic or just plain logic? Now, the term plain logic may not be familiar to many of you, but hopefully by the end of this presentation, you'll get some idea of what that is. The plan today is we're going to give a last kind of review of the grammar, and then the traditional logic, why it kind of fell short for thinking, and then where math logic stepped in to fill in some of the gaps, but at the cost of using the language component, and then bring in Aristotle's insights to maybe improve on the way logic has been taught and understood. And then we have a comparison between math logic and the kind of plain logic that I'm talking about. And then do some basic deductions with that. And that's pretty much what the plan is. So the first thing I want to bring out is why have this question about math logic and plain logic. My take on this is that, do you recall, for example, when you learn logic in school? My guess is that you probably, for many people, did not learn logic in school. Probably because perhaps logic as a science and art has been changed in a radical way since the 19th century, beginning with George Boole, with algebra, logic, and then the advent of people like Gottlob Frege and Bertrand Russell, Alfred Whitehead, bringing up logic based on set theory, based on math function, that give out a different impression of what logic is, changing the way logic is understood and taught in school. And so because of that, many people have kind of lost the notion that logic should be something that is a
method, a tool, a skill for thinking in everyday decision making and in everyday discovery of the world. So that's why I think the problem arose. Oh, did I do so? So what that means is that over time, people did not learn logic in school, and it waits perhaps to have an introduction course in that, and then at the same time, maybe more logic than mathematical logic is taught. Is done much higher.
You're in and out over the Zoom. We can't hear you.
Oops. Okay, I will speak up. I thank you for the feedback. So consequently, what that means is that people don't, as I said, people don't know what it is or believe it to be for other people, perhaps the experts, but not for themselves. And then, of course, as I said, young people are not taught logic as a formal course. And so that the early 20th century kind of logic is now pretty much understood as math logic and requires a lot of thinking, but not for the sake of grasping the world, but rather to grasp the symbolism, the kind of abstract, high-level form of mathematical, symbolic manipulation of terms. And so I think that what that means is that logic pretty much goes out and it is disfavored. And if we ask people, everyday people or ordinary people, they pretty much don't see it as useful even, because it's too removed from thought. And what I am doing today is, hi Frank, is to recenter logic, to make it more language-based. And that way, it becomes something that perhaps even children in the middle school can start learning logic in a way that will augment their way of thinking sooner than having to wait until much later to gain some basic form of education on that. So my take is, if a child can speak English or any human language at all, then he or she can learn this form of plain logic to begin thinking objectively. And so for labels of convenience today, I'm going to distinguish 4 forms of logic. One is ancient logic. That is the logic that got started by Aristotle, and then it kind of disappeared soon after the collapse of the Western Roman Empire. And then from then, we have something called traditional logic. It is the logic that is, of course, based on Aristotle, but it got changed quite a bit through the new Neoplatonists. It started with Porphyry's Isagoge that gave us a different conception based on a different ontological framework, the Platonic framework, to talk about the various apparatus and methods of logic. And it developed quite slowly, but from Boethius in the Latin Romanized version of logic, it is preserved and carried, but with that kind of hybridized version of logic, which is no longer kind of Aristotelian, although it can still bear the name of Aristotle. And then it went all the way to the 1800s with John Stuart Mill and others, which gave us almost like a kind of last bit of inductive methods, Mill's methods for discovering what's going on, but actually Mills used the hypothetical deductive system there as well. But still, we got what is called traditional logic, and then starting in the 1850s and so on, especially with 1879 with the publication by Gottlob Frege's works on the concept script, which is the German, English version of the same text. It became completely mathematized as logic, changing the way people think about how to use logic even. That's what happened there, and it got popularized with the publication of Bertrand Russell's and Alfred North Whitehead's Principia Mathematica. That's when math logic came into full bloom, and it became popularized in Great Britain and then in America from then on. And because of that, the inertia through this institutional endorsement makes it the type of logic that continues on today. And then the last thing, the term that I want to use now is plain logic. This is the logic of the natural everyday language, as based on the rereadings of Aristotle's Organon. In a different order, because when Aristotle's works disappeared soon after his death, there were a few scholars who tried to put in a certain way which treatise should be read after another and so on, to give a kind of a prerequisite to this, to that, and the next. They had a different order, and to that extent, it affected the medieval use of an understanding of logic in a really negative way, in such a way that traditional logic was kind of ossified. It became dogmatic, and it stayed rigid from then on, which allowed for math logic to overtake it, because it did not have any kind of resilience or flexibility for new changes during the Industrial Revolution. And so plain logic returns to the original math logic, Aristotelian logic, using Aristotle's work. And my specialty, because I read this recently with my online group and so on, is on the rereading of on interpretation. And it's in that same, a different order of the reading that allows for a recovery of some of these ideas that are really crucial to putting logic back as part of a language-based form of logic. So that's what I'm going to do today. So the benchmark type of characteristic that I wish to do is to put in context where logic belongs and how it fits in with the rest. And it begins with speech, because we are human beings, we speak a certain language. Speech, by speech I mean vocal utterances conveying meaning and thought in the moment, right? Like right now, we are doing it right now, and after my voice carries through the air, it disappears, it's gone. But then of course we have written marks, we have writings that preserve the kind of meaning that transmits from one mind to another across time and space. So we are now the beneficiary of the writings of Aristotle and all the other philosophers, because of the transmission through time and space via written marks. That is also considered speech. Then what is thought? Thought is that mental activity, reading or grasping something of reality. So a thought is always clothed in a sentence. And now, so what is a thought and a proposition? The distinction is really for the sake of transitioning the mind from talking about thought using grammar, because when we use a language, we have a certain set of grammatical rules for constructing how to put a sentence together. And so when you use the word thought, you associate that with grammar. But if you want to say, how do I use my thought and string a number of thoughts together, put two and two together and to form a new thought, then we consider that thought a proposition. And so a proposition is a thought that is either true or false as evaluated from the supporting evidence that one has and is done by some method. And so while a sentence in some human language refers to a thought, as I said, as studied by grammar, a logical statement in some logical notation refers to its proposition as studied by logic. And so the three verbs that I want to ask you to keep in mind as part of the benchmark characteristic is that a person who is skilled in a certain form of logic can do certain things to make a declarative sentence into a proposition. And the three words are: a person skilled in traditional logic can regiment a declarative sentence to its proposition. A person skilled in math logic can translate the declarative sentence to its proposition. And a person skilled in plain logic can transcribe the declarative sentence to its proposition. Now, the three words allows you to see that regimentation has a certain kind of uniformity, has a certain kind of making things that are a certain set, rigid way. Translation means it's a completely different language altogether, requiring a shift pretty much from, let's say, language to math, for example. And plain logic is just a transcription, a straight transcription from thought to proposition. So that's the claim that I'm trying to make, and I'm hoping that I will convince you by that. So what we have here now is the first part, a fast review of English grammar. Now, from looking at this audience in front of me, and I'm not sure about the online, but I would say that we all know what grammar is. But in the case that we don't, and if we have children, we can see how useful grammar is for composing thought. So that's what I'm going to do today. Briefly, so I'm on time, right? Yeah. So first of all, I want to say that a sentence expresses a simple, complete thought. A sentence comprises of words grammatically arranged, and words in a sentence are grouped together into units of meaning with different roles or jobs to build the structure of a thought. A unit of meaning or word group points or refers to some concrete things in the realm of discourse for the sake of thinking. And so we all know what the units of meaning are. Those are words, phrase, clause. And of course, words can be simple or phrasal or compound. Now, I'm using it and basing all of this on the English language, but I'm sure that if you go outside to those people out there celebrating Chinese New Year, they will talk about a different form of language and they will have a different way. But pretty much the language and the grammar will have similar things, and I think we will see some commonality there as well. So when units of meaning are arranged grammatically in an indicative or mood way, they form a declarative sentence saying something of something, affirming or denying the something, which can be either true or false. Now, here's a distinction I want to make, which I will emphasize later on, and that is a clause is not a sentence. This is something that math logic doesn't really believe in. So a clause is a unit of meaning. Despite having an internal structure comprising a subject and predicate, it cannot affirm or deny, hence cannot be true or false. So that's what a clause is. A clause has the potential to become a sentence, for a sentence may comprise simply of one clause with the speaker's intention that it be a complete sentence or a complete thought. And so because of its potential, a clause may be deemed a unit of thought that is intentionless building block during one's process of forming a complete thought. And so a clause has a certain pattern in any language. And this is a discovery that Aristotle made. So here's my picture of a clause. And now you know if you have been taught a certain way of English, starting, let's say, with 5th grade and 6th grade in elementary school, you know this, this diagram version of it. So here is the clausal line. I call it the clausal line. I pick all of this up from Homer House, from Descriptive Grammar from a 1950s book. So I'm not even familiar with this. I'm just putting this up. But it's so cool when I read about it. So I said, okay, let's use this. So here's the clausal line, and here's the animation of a clause. Let's see it again because I like it so much. So there's your clause. And so that can be called a unit of thought for the sake of forming a full sentence. So there's your unit of thought, and then here are some examples of what a clause can be. Teachers teach. Students learn. Students are pupils. Students are angelic. Teachers teach grammar. Students learn grammar. Teachers give quizzes to students, or teachers give students quizzes. Students give teachers results. Teachers call students pupils. Teachers call students angelic. Students laugh. Teachers beam. What I have just given you as this set of examples is the complete list of all possible structures of the English language in diagram form. So the structure of a unit of thought, again, is this clausal line, animation. There's your total subject. There's your total predicate. And within the total subject, there's something called the simple subject. And within the total predicate, there's this simple predicate. And that's the minimum for a clause. But of course, you all know that a simple clause like this, that's not enough to have a complete thought. So let's look at the layout of a total subject. And the general structure, as we said, is here's the simple subject, and then it has all these modifiers, and a lot. And there's the full total subject for you. What about the total predicate? The layout of the total predicate depends on two elements. The simple predicate, of course, and also the simple predicate's completers, if any. And of course, the simple predicate depends on what kind of verb that is there. The state of being verb, it requires a subjective complement. An action verb that is transitive requires a direct object. Or it also can include an indirect object. So that's a different layout. So you can see upper right, layout number 2 is action verb transitive with a direct object. Layout number 3 has an action verb transitive with both direct object and indirect object. Layout number 4 says it's a transitive verb with direct object and with an objective complement. And then lastly, an action verb, intransitive. It doesn't need any completer at all. So there it is, all 5. So the layout of the total predicate then depends on these two elements, the simple predicate and some predicates completers, if any. So again, I'm seeing the time, and I still have some time. Let's continue. So basically, this is the layout of first one. It has the simple predicate and the subjective complement. Let me go back just a little bit. You notice the slanted line. That's how you are able to tell that this is a state of being verb. It has that little slanted line. And then for the other kind of predicate, it has the little vertical line there. And that gives you the direct object. And then it gives you also the indirect object right there. And then all the modifiers. And then the direct object with an objective complement, it has the hybrid version of this. It has the complement from the original state of being verb there as well. So that has the same structure. You get the fourth layout. And then the last one is just a predicate that is intransitive verb, and that it's all by itself. It doesn't need any completers. So you have then the structural elements of a clause is that there's a simple subject, simple predicate. That's required. The rest are optional. And in our English language, we have all of these units of thought, elements of units of thought there. And then we have a notion of what are the parts of speech that can do the job of any one of these. And they are the nouns, the pronouns, the verbs, and the adjectives and the adverbs, and the interjections, and so on. And one feature of English is that we don't have inflections or case anymore, as opposed to Latin and Greek. But we still have some in the pronouns and in some of the words that we use. And so we call these the nominative, the accusative, the dative, the genitive, and so on. And then about the modifiers. Now you know what modifiers are, adjectives and adverbs. And it modifies whatever that's the X there. And you just read from left to right as you see here. Example would be the bright, hot sun, or super explosively hot stars, or very, very busy bees. And then you have the modifiers. What can modify what? To modify a subject, you need an adjective, predicate, an adverb, indirect, direct object, adjective, and so on, all the way to the bottom there, which says that to modify a whole clause or a whole sentence, you need an adverb. And so the example of a unit of meaning, as you can see structurally, is there's a word. It can be simple word, compound word, phrasal word, group of words. It recursively is a phrase. It can have an appositional phrase, prepositional phrase, verbial phrase, such as participial phrase, infinitival phrase, gerundial phrase, and of course a clause. The whole clause itself is considered also a group of words that can be a modifier. And the examples are there. And so we talk about the jobs or the parts or the units of meaning, what can be done. So all these noun, pronouns, and so on, a word can do all of them. What about a phrase or a compound phrase or compound word? Yes, it can do all of these things. But an appositional phrase can only work as a noun or a pronoun. A prepositional phrase like under the mat, or on the mat I should say, or under the table. When you have a prepositional phrase like that, it can only work as either an adjective or an adverb. Participial phrase, same thing. In infinitival phrase, it has one extra, which is it can work as a noun. A gerundial phrase, just a noun. And a clause can do those things as these phrases can. So as you can see, these are the 5 clausal patterns that I just showed you. And it depends on the verb that you have there. And these patterns that we have just talked about gives you these examples that I read out loud to you. So I'm going to skip over quite a bit. I'm judging the audience to see how engaged they are. So, a clause is not a sentence, as I said. A unit of thought is often and not yet a complete thought. But if it is a complete thing for you, then you can make it a sentence. So it is a matter of choice. And so a complete thought, by definition then, is the smallest self-contained, self-intelligible unit of a thinking process. And lastly, let's just jump to sentence. It's a group of words expressing one single complete thought. And so by means of these 5 clausal patterns, we can form 7 types of simple sentences. And from these 7 types of simple sentences, we can encode and decode the entire English language. And so logic fulfills the language requirement if it can transcribe these types of sentences. And so these are the ones that I've shown you before. And if we can do this kind of propositional notation, and I'm sure math logic can do this, but I won't show you that. But that's the basic connection between grammar, language, and logic. And so now let's transition to the logical part, where traditional logic fell short and math logic got right. Now, certain limitations of traditional logic, there are 3. With traditional logic, we regiment declarative sentences in a crude and low resolution way. I call it low resolution because even though Aristotle was the founder of logic and grammar, and so it has the same subject predicate structure in both the grammar as well as logic, and yet the logic side of traditional logic here remains stuck at just subject and predicate. So it has only 2 terms. It's a subject term, predicate term. And it can only do simple sentences only. You see that in our language we have a sentence that can have 1 independent clause and 0 dependent clause, or 1 or more dependent clause. So it's a combination of those. You get simple sentences, compound sentences, complex sentences, and compound complex sentences. Well, traditional logic can only deal with simple sentences. And the complex ones get regimented as simple sentences. And it, of course, has no compounds, because compound sentences must be broken up, and then they are considered not single thoughts, not regimentable to a single proposition. And so therefore, the terms as a whole is either a subject term, predicate term, and that's it. Complex terms don't get analyzed at all. And relationships, too, don't get analyzed. And here's an example of a relationship. John is married to Barbara. Now, we notice that the content includes 1 relationship, the marriage relationship, and there's the subject, 1 subject, the man, there's another one, the other, let's call it spouse. John is married to Barbara. So there are 3 things to be discerned, and yet, when we regiment the sentence, it's just the subject term, John, and the predicate term, being married to Barbara. And that's it. There's the limitation of traditional logic. But the nice thing about that simplicity is that you can have a deduction using 3 terms. So Aristotle is the first to discover the deductive method for thinking, one that preserves truth. So syllogism, it brings two propositions together as evidence, the premises, to infer a new proposition of the conclusion. And the 2 premises must share 1 term in common. For illustration of his discovery, Aristotle uses the simple propositions which have exactly 2 terms, the subject term and the predicate term. But the theory, if we reread it, is not limited to them. And for everybody who is not familiar, Aristotle has this major premise, minor premise, and it shares the middle term there, which is the M there, and then it drops out in the conclusion. So what's left is just the subject and the predicate term, or the major premise and the minor premises in one conclusion. So when the shared term, the middle term, can be correctly cancelled out, then a new proposition is validly inferred. And so here's my example that I want to show. Anyone obsessed with current trends is attracted to social media influencers. Someone mentioned that I need to make this presentation sexy, so I had to bring in something to relate to the people here. Yes. Well, okay, fine. So what? Well, every current trend is something based on K-pop music. Okay, so can there be a valid conclusion that come out of this? If you look at these 2 sentences as an intelligent English speaker, you can see the connection. But traditional logic cannot give you the answer for this. And that's the sad part. Because why? It has too many terms in here that has to be broken up, because if you only break it as subject and predicate, there's not enough granularity to find the right middle term to cancel out. And so that's the problem that's being taken here. But I'm just saying, if you intelligently can look at it, you can see the cancellation right there. Anyone obsessed with something based on K-pop music is attracted to social media influencers. And that's the real conclusion that you can draw from an intelligent person's perspective. But traditional logic can't do this for you. Okay. So the syllogistic deduction is valid, fitting the brief of Aristotle's syllogism. But as I said, traditional logic falls short. So math logic to the rescue. So what does it have? The starting point is the math function. Example of a math function is, if you see this formula up there, f of x, being defined as x squared plus 3x plus 5, what do you see? Oh, well, that's just a function. But then if you add a 4 and replace the x with a 4, then it's a thought. It's a complete thought now. And the thought says 4 times 4 plus 3 times 4 plus 5, which totals 33. So f of x is a mathematical function, and it works in this way. The capital F can stand for any incomplete expression that we want for the sake of representing a thought. And so these are the examples, and I put in the Greek letters just to say that these are the things to fill in the blank. So the first one is love. So you have to put in 2 variables, or 2 things to say X loves Y, or alpha loves beta, something like that. The next one is capital T, and that's, it requires 3 items to fill in. So it's a alpha throws the beta to the other one, gamma. And then the third one is just one variable. X is being mirthful, or alpha is being mirthful. So each of the function is incomplete or open and is not yet a thought or a proposition until all the needed arguments, the lowercase letters, are filled in. And so the function L, as I said, are the ones that I just talked about. And so these bare bones functions, once saturated with arguments, to use Gottlob Frege's term, produce these atomic propositions or thoughts. So math-based logic is as follows. You have to have a well-formed formula. It has to be complete. And then the logic is wholly deductive. The deduction is based always on the form of a proposition. And that is, the structure is determinative of validity, not the material contents. So given the sentence function as foundational, math logic has at its core a branch of logic called propositional logic. Built on top of that are orders of what is called predicate logic. And so the foundation then is propositional logic, and this is what it looks like. These unanalyzed primitive well-formed formulae are like lowercase p, q, r, s, t, and so on. And then the connectives to make the longer well-formed formulae are these connectives, and, or, not. The horseshoe there is the if-then, and the triple bar is the if and only if kind of binary connective. And then the open functions are predicates like capital F, capital G, capital H, and then the variables are the lowercase letters, W, X, Y, Z. And then the constants are the real things like John, Mary, Barbara. Those are the small case A, B, and C. And then the quantifiers, you have to say how many of them. Some, all, things like that. So they invented a different upside down E, upside down A, or reverse E. And so you get these for every or anything X, that's for the A. And then there exists at least one X, that's the mirrored E. Examples are Socrates is a thinker. Now Socrates is a constant because it's a real thing. So it's lowercase s, and the thinker is the predicate, and that's the function. So capital T, small case s, that represents Socrates is a thinker. Now, all men are thinkers. It's pretty much the same sentence, right? Except now you generalize from just one guy to all human beings. But you have to use this new way of, it's math-based. It says that, I'll read it. For all x, man is x, or x is man, if, let's say now I have to change my mind to say, I'll just read it. For everything x, if x is m, then x is t. And then you have to switch in, m means man, and t means thinkers. So that's what this formula is in math logic.
That's the question.
Yes?
I don't understand the last example syllogism. It looks to me to be incorrect. You'd have to have it prefaced with, you have to have somewhere in there, Socrates is a man. All men are thinkers, therefore Socrates is a thinker. So I'm not buying that example is correct.
I'm not giving you a syllogism. I'm giving you a way to describe, to translate a sentence. So if someone has a sentence that says Socrates is a thinker, period. Then how do you translate that to math logic? That's it. And then if someone has another sentence that says, all men are thinkers, how do you translate that into a mathological notation? And that's it. There's no deduction yet. These are not premises yet. These are just simple sentences that I want to bring up. Thank you for the question. So these are just examples of how to translate English sentences into math logical notations. So, so of course, that was just the predicate logic at the first order. But then there's higher orders, and what are they? Those are the syntactic meta-language for expressing and asserting axioms such as, that is to say, stipulated postulates, defining functions, relations, predicates, intentional meanings, and then defining sets, because after all, math logic is based on set theory. And so the example, now I'm not believing any of this, I'm just describing it. So look at determinism. How is it defined? And you can see the formula there. It's for every x. If x is a, then there exists a y such that y is f and x and y are b. I have to read up again on what all that means, but what that says is all actions are determined by antecedent factors. So if you have the English sentence, all actions are determined by antecedent factors, this is how you translate into the mathematical logic. Now, if you have free will, you can also translate the same way. Here's the English sentence below there. Some actions are not determined by antecedent factors. Now, how do you translate that into math logic? There's a symbolism right above that. You see how different determinism as a math logical form is, and you see how different free will as a mathematical form of that statement is. But now, if you ask yourself and step back and look at the two English sentences, what do you notice? What you notice is that one is the complete contradiction of the other. And that's what we, in everyday thinking, using English language, thinking for ourselves, we look at these two and say, these are completely contradictory statements. Either one is true and the other one is false, and vice versa. And that's it. And yet, if you look at the forms of these two in math notation, it's very difficult to know that they are contradictories. You have to really prove it. You have to form a proof to demonstrate that one is the contradiction of the other. But in English, you already can see for yourself that the two are incompatible. So right there is the cost of math logic. It removes language altogether, and it requires you this form of notation that is quite complex, and it's not useful for thinking. But it's very good for databases and for using it in large language models that uses statistical analysis and probabilities and so on. So that's what we have here. And as an example of a proof that you wanted to see, this is a proof that George Boole in 1847 or so, around there, yeah, 1847, when he wanted to show, he's a defender of Aristotle, completely impressed with Aristotle's writings, but he really tried hard to see if he can use Aristotle's logic to make this proof. And here's the proof, or a deduction. Look at number one. No rhombus that is a rectangle is a square that is a quadrangle. That's the premise. Now, what we want to do is to conclude that no quadrangle that is a square is a rectangle that is a rhombus. Now, it's a mouthful to cite it out loud, but how do you prove this? Or how do you form a deduction from one premise? So really, it's difficult, but here is what we now can do with math logic. So there's the premise, and there's the conclusion to be proved. And it says exactly what it is in English, pretty much, but with the notations that I have just described. And then here's the number of steps that you need to draw the conclusion. What you can see in step number 2 is a kind of commutation. The things to the far right is just the steps to go from one given to the next. So from 1 you can commute, 2 also you commute on each side, and then you have a implication. You change the horseshoe into the or sign by saying not or, and so on, not a P or Q, things like that. And then you do more commutation, and then you reverse the implication. You get back the horseshoe. And that's what you see. And you learn this if you go to any logic course at the upper level in college, and this is what you get. Okay? Another proof. That's proof number 1. Now, remember that social media influencer statement earlier? Here's the proof that math logic can do. Again, anyone obsessed with current trends is attracted to social media influencers. Every current trend is something based on K-pop music. So the conclusion to be proved is anyone obsessed with something based on K-pop music is attracted to social media influencers. So here is the notation for the 2 premises and the notation for the thing to be proved. And you can already see the line, the blank space below. That's how, I guess that's the length of the proof that you will need to do to give that conclusion. You have to transform a certain universal instantiation, existential instantiation, implication, assumption, modus ponens, simplification, twice, disjunctive syllogism, conjunction, the ending of the conditional proof, and then existential I made a mistake. The last one should be universal generalization. I just realized. Okay, so there's a mistake there, but it should say universal line 15, justification is 14, comma, UG. So I just found out. Okay, sorry about that, but there's the proof. So how does plain logic integrate Aristotle's insights about thinking? Now this is where my research and the things that I go on with my regular online participation I mentioned, Jamie mentioned earlier. Just for comparison, here's what you saw earlier about math-based logic. Its completed function or the sentence is foundational, logic is wholly deductive, and it's the form, not the material contents, that determines validity. And then because of that, it has this propositional logic as the foundation. Here's the language-based. The word or the terms making up a sentence is foundational. It's the smallest thing. Logic is both inductive and deductive, and both the structural form and the material contents of thought are determinative of validity and cogency. And categorical logic, or the logic of the syllogism, to see through the middle term, is the core. And then plain logic is its natural development. Now, the third bullet may require a little bit of thinking about that, and let me read my notes here. what we have is that an example is the division operation. If you have if you see a math arithmetic problem, you see a division. That's just a form, and if you see the division sign, you know the procedure for doing division. But you can't divide with any two operands, because you can't divide by zero. So the zero part is the content of the whole sentence in the long-handed division. And so division requires a little bit of content. You have to know the content to say you can't do that. And so in exactly the same way, in many of the logical operations that we make, we should also take notice of the content to know if that's the right way to do things. And that's why both structural form and material content are required. That's the only point that I just wanted to raise. So,
Could I ask something? I don't know if this will make sense, because I'm trying to follow you, but I may not be following you. So there are some problems that are non-computable. They're just, and so I'm wondering, are there any sentences that cannot be translated into language-based?
are there sentences that are not translate? I don't know, because when we human beings think, we think in language. So if it's not translatable, then how did we get the thought to begin with?
Exactly.
Yeah.
So there's a whole list of problems that are non-computable, and we know that,
Yes.
right? And so the question is, how did that come about? How did we arise?
And that's what I can think of is that these are paradoxes, and part of the paradoxes from set theory and from the mathematical logic is that it's based on top of a certain metaphysical ontological framework, and it was not resolved in them. So that's why we have these paradoxes, liars' paradoxes, Barber's paradoxes, and all of these paradoxes that then bring out the problems about how to codify, how to resolve them, and that brought out more, let's say, there's a part in this presentation that I skipped on what Susan Hack called deviant logic. So there's a math logic that we have that I've been talking about, but then there are special levels and different varieties of logic that addresses problems, paradoxes, like the paradoxes of the explosion problem, meaning how if you have certain things that are false, can you get any implication out of that? So these problems are being handled by paraconsistent logic, relevant logic. The people in Australia, they talk about Graham Priest's works on these logic that deals with multivalent logic to address some of these things. My problem is that, or at least the scope of what I'm doing, is that I want to have ordinary, everyday people to use logic in a way that adhere to the law of non-contradiction, in such a way that you yourself should not have any contradiction in your head. But outside in the world, people can have all kinds of contradictions that they want. But the idea of good thinking is you eliminate contradiction from your mind. And the problem you raise is there are problems that are being addressed, but can you say it in a sentence? Can you say it in a paragraph, and so on? That's what I'm focusing on, to be able to say things and then to be able to justify it and prove it, as opposed to say a whole bunch of things that I don't have a way to prove. So my scope is only for adhering to the law of contradiction and not for this principle of explosion or non-relevant logic and other forms. So that's my answer. Yes?
Could a contradiction be, not sure about the language to use, notated as this and that? So like logic gates, like a contradiction, it would be both things simultaneously.
In reality, there's no such thing. The law of non-contradiction says nothing is both A and non-A at the same time and in the same respect. So if you have some thought in your mind that has that kind of a condition, like you say something on Monday and then on Tuesday you say the opposite thing, well then you contradicted yourself. That's what a contradiction is.
Could you phrase it as this and that? In other words, it's two sides of the same coin.
Yes, you can do that. You can say.
And so, anyway.
No. You
Or you
can.
could say light is a particle and a wave.
Yes.
Yeah.
We know that it's both.
Okay. Yes. Yeah. You can state things in a complete sentence, and that can be done with a conjunction like that, and math logic can definitely translate it into math logical notation, and that's not a contradiction. It may seem like that, but no. Okay. So some insights that I wanted to highlight from this work on interpretation. Human level awareness, as opposed to, okay, I'm a little behind now. Okay, so let's skip to chapter 4 there. What a phrase is, why and how it is recursive, and why and how it always is a part of some whole. This insight is how this insight from Aristotle can rescue the language-based logic, because as I said before, the medieval scholastic logicians, they made it very rigid that a sentence, a proposition is either is subject and predicate, and that's it. But this chapter 4 here says that you can actually make it recursive, so that you can expand the notion of what can be understood as the whole single proposition, and not limited to just subject and predicate. Another, I'm skipping to number 8 there, how to achieve a unity or singleton of assertion through recursion and connectives. And then chapter 11, what the structure is of a complex term, and how it requires recursion again, and how it is to be used to maintain a unity of assertion. Now the problem that logicians wanted to avoid is to have a disunity, or to have a sentence that cause confusion and when you can't put them together. So unity is, or singleton, or one, is a very important concept, and that is why the medieval traditional logicians kind of limited themselves to just subject and predicate. Then it's just one thing. Yeah, easy, except it's not complex enough for longer, complex thought. So what we see then is that for our purpose, chapters 4, 8, and 11 advance the development of plain logic. And so I just want to say, Aristotle says that you can still have one thought when two clauses are linked by a connective, a conjunction. meaning a unity of thought. And I'm not sure you can see very closely, but the notation that we moderns use is we put a period at the end of a sentence. That tells us that there's a complete thought. And so right before the and is the comma. So that's what you see. This is not a complete thought, or this is not a unity of thought, but two distinct thought, because there's a period before the and there's another period. So there are two periods in there. So that's why it's not considered a compound thought. It's just two thoughts, right? Also not a unity. If, then period, then period. So it is clauses that are linked by connectives, not sentences. This latter is characteristic of math logic, since the sentence is its foundational core. And what about the other two chapters? So the word or name is the smallest significant unit to stand as a term. Everything else built from there in a self-similar fractal-like way, growing the term to any complexity befitting the single thought.
Tom,
So,
really quick, I have a question on the chat
okay.
and a comment. This is from Alvin. One fundamental problem with using language in logical structure is the lack of precise definition of words.
Okay, good comment. I agree. I agree that it shows then that part of logic or an education in logic requires that the students, young people, to respect language, to see every word as required definition before using. But because people don't have an education in logic anymore, they don't see the need to have precision in the words that they use. And because of that, there's no respect for words. And I remember a movie, was it The Last Emperor of China, where Peter O'Toole played the tutor who was sent to teach the young emperor. And in that scene, the young emperor asked about, what do the people in your country call? And the O'Toole character says, they are Scotsmen. And then the emperor looked at the emperor the emperor looked at the tutor and said, but you don't wear skirt. And then the tutor said, Scotsmen don't wear skirt. They wear kilts. Kilts? Yes, kilts. Why? Because words are important. So I find that really interesting and educational to see that, as Alvin said, people use words very loosely. And because of that, they don't have clear thinking in their thoughts. And what Aristotle, proper education in logic will lead people to make sure that their words are precise because they respect words. And that's what I think is lacking in today's education. But getting back to the topic, thank you, Alvin, for this. If you see subject and predicate there, you can see that John throws expertly a fast ball. But you can see that you can expand the analysis by have this self-similar structure being expanded. And it goes on and on and on. You can do it on the predicate side, but you can also do it on the subject side. And this is just the example. I'm just speeding through things up. Okay, so it means that, let's skip this slide. this is too much. So what we have then is we have the new term. A term is what is either a subject or a predicate, but you can expand it, explode it to the level of complexity that you need for your thought. And this is what Aristotle has. We have the singular term, we have the universal term. Everybody already knows that. For the singular, we have proper name, proper noun, definite noun phrase. And then we have the simple term, such as the common name and its complement, like a and non-a. And then here's the complex term. We have the relational term, and this comes from the categories of Aristotle's. For example, larger than a millet grain, in the Lyceum, last year, has on shoes, but we can make it more complex, like throw the ball to first base, or drive some friends to the party. Or even more complex, like my wife's tacky wedding ring from her 5th ex-husband. That too can be made into one relational term with multiple terms within it that can be nested and can be understood. So in a way, when you read a novel or mysteries, Sherlock Holmes, the power of observation is by one sentence, and you see all the little details that are there in one sentence. Now, it is Sherlock Holmes' power of deduction to pick out one little item in his observation and then find some connection to another thought and another thought and so on. So that's what we're doing here by seeing the relationships and being able to capture that as one term, but then can be analyzed in multiple little nested items from within. Same thing with composite terms. We have things like wet and cold, so that's a conjunctive, obviously. Strong, but not well. So also conjunctive, but with a little bit of a negative in there. Cranky, if hungry, or true or false. So you can see them as conjunctive term, acceptive term, stipulative term, and disjunctive terms. All these terms can be understood and can be, for someone who is interested in logic, they can definitely see the usefulness of there. And so from there, we can see the power of a simple sentence as being transcribable into more complex one. So this is Aristotle chapter 11 and on interpretation. You can see he wants to avoid crammed assertions. So he wants everything to be under a single assertion, but a single assertion is not the same as a simple assertion. And we already know a simple assertion is either an affirmation or a negation. And then, but within the single assertion, there's also the composite assertion, the positive assertion, the compound assertion, and also these, and the traditional logicians only talk about these two items right there, universal assertion and partial assertion. I call it partial rather than particular assertions, but it's the same thing. And the way that Aristotle, the translator that I'm using here, used the word assertion, but you can just rename it to call it proposition. That is the same thing. So that's how much that we can get with the insights from Aristotle's when we read it more closely than we have before. Because one of the reasons why people don't read Aristotle's again is that during the transmission of that period after the fall of the Western Roman Empire, the Neoplatonists, Porphyry, did a lot of the translation of Aristotle, but then he put in a different ontology on top of that, and he changed quite a bit of what should be preserved, but then that portion get carried into the Christendom, and then Boethius translated that and put it into Latin, and then they never read the Greek again. So the logic that we got is a lot of it came through that direction, through the Latinized direction, as well as from the Arabs who carried it for a long time, and then it emerged back during the rediscovery of all of that in the 12th century. So anyway, what I'm showing now is the comparison of the plain logic notation with the math. So I'm going to go really quickly here. I can see, whoa. So again, the idea is we go from the element, from the smallest thing, which is a word, to the molecules. And so a proper noun or name is something that gives you something from reality. A word designates a category or a property. And then a phrase fields a group of things. And then a clause is likewise transcribes the same thing. So given the two examples that we had previously, Socrates is a thinker, all men are thinkers. Math logic translates them in two different forms, as you can see. Capital T, small case s, for Socrates as a thinker, and then all men are thinkers is translated that way. But what about plain logic? So that's a question right now, but I'm going to say that it should have the same form that you will see. Just some basic characteristics of identification. The things you perceive with your eyes and listen to your ears are the individual concretes. The concepts are either universal and abstract, and that's in your head, and then our thought, judged if true, corresponds to a fact. So this is, I'm adhering to the correspondence theory of truth there. So truth pertains to the propriety of a thought to integrate its concepts to identify successfully a fact. And the truth of observation is justified self-evidentially, because you're using your eyes, so that's self-evident. And then the truth of any thought is justified inferentially. Okay. So again, I'm using things, concept, and thoughts. So now the things are name, pronoun, definite description. And then the concepts is, as I said, the complex terms that you saw from chapter 8 and 11 on interpretation. And the thought can be simple as well as composite. And here is the logical form in plain logic, essentialized. Here's the logical form of identification. There's a subject and there's a predicate, but it has all these plus or minus in front as a way to read the form. And you can look at that. The first one is yes or no, not. And the second plus or minus is some or every. And the third one is either a positive S or a non-S. And then the fourth one is or isn't, and P or non-P. And that's how you read this logical form of identification. And I call that a dyad because it has two little components in it. Okay. And then in any dyad, the subject refers to existence, and the predicate characterizes their identities. With one or more modifiers, because we saw in grammar the kind of modifiers that people have, subject, if the modifiers are in the subject, it refines the quantity or the specificity of the existence, and if the modifiers are in the predicate, they adjust the quality or variety of their identities. And then failure in either of these two jobs, the dyad as an integrated unit fails in subsequent identification. And the example that I want to resolve right now, just because it's here, this sentence is false. Now, this has caused quite a stir since the 20th century from all sorts of papers and philosophical works. But from my perspective and from the reading of Aristotle's, it's grammatical, yes, but it is not a sentence. even though it uses all the words, because, and if it is not a thought, it's bad because it fails one of these two. It fails one of these two jobs of the dyad. And with the what you saw earlier in this logical form, Aristotle has 8 of these propositional forms. Now, traditional logic talks about only 4 of these forms, the A, E, I, O there. Every S is P, every S is not P, some S are P, some S aren't P. But if you read Aristotle's work, you see the others. Usually they are singular, and that's sometimes folded into the universal in traditional logic. And then there's the last 2, that's for induction. And then using the notation that you saw earlier, it would have these minus plus, minus minus, plus plus, and all these extra things that are there to give you the form of the assertion. And let's see if we can jump. So some examples is some atoms are radioactive. If you look at all these pluses and all these, it's right there, A plus R. But if it's plus, you can usually omit it, because in ordinary, everyday sentence, you don't say, yes, I have done this. You should say, I have done it, right? So the yes part at the front disappeared. Only when it's negative, then you say no. But usually the affirmative is assumed. So that's how you see the structure. Another example, not everything is rosy. Now it has 2 negatives in front, but you reduce it to plus T minus R. Not a snowflake is 5-sided. There's a full notation, but then you can do some manipulation, and it's minus S minus F. Every non-citizen is a visitor. Again, notations there, and you can see that every non-citizen is a visitor to the bottom there. And with this notation, you have compound terms. Compound terms are done using angle brackets. So the example here is, this is a red house. How does it work? So the this requires the multiplication sign that says a single thing. This, okay, is the second plus here. Can you see this? I don't see my arrow, so let me put the arrow here. So here's the is, and the red house is a compound term. And it has the same dyadic structure again, plus R plus H. And then that same thing can be done in the subject part. Red houses are pretty. So now the angle bracket is the subject, and it has that dyadic structure. So it's technically it should say every red house are pretty, or yeah, all red houses are pretty. And then round square don't exist. It's a negation within the larger something. But anyway, and you can see the notation down there to allow for and not, if then not. And for relationships, we have the English notation, but also the original Aristotelian form. Just briefly, Aristotle in the prior analytics presents propositions in a stylized form. And the example is A belongs to every B, and B to C, and so is A to C. And so with that kind of notation, you can see that it's yes, P belongs to some or every S, or not. P belongs to some or every S. So there's the A form notation. It has only one thing that determines the form of the proposition, whereas in the English form, it's distributed to two signs, one at the front and one in the middle. So relational terms, like on the mat, it uses the A form notation, and you can see right here, R, it has, it's a relationship. Remember earlier we said John is married to Barbara. Well, the relationship is R, and requires two items, and then oops, I think I made a mistake. I should have erased the A in front. But anyway, the example, the full example is the cat is on the mat. So here's the cat is on the mat. And second sentence, the mat is what the cat is on. It uses the same relationship, but it swaps the placement. And that's what you see there. And what about Dick throws the ball to Jane? Dick throws the ball to Jane. Now, is it not the case that the term is dyadic? It has two parts. Then why is it that in this sentence it has three parts? Well, this is a simplification of the more correct way, which is Dick throws the ball. That's the full term to Jane. So for simplification, you can remove this bottom part to see the top. And then another change or not development is the causal term. That's in square brackets. And with square brackets, you can represent the unanalyzed propositions like P and Q in this way. And the example you can do is a sea battle will either take place or not take place tomorrow. That's an or, that requires an or conjunction there. And this is just plain logic at a glance. So originally what you see as the sentences from clausal patterns, and here is what you can expect with propositional notation, and definitely plain logic that can transcribe them into something that we can use for deduction. And there are, of course, rules for talking about how to make the deduction work. These are the rules for syllogistic validity. There are also rules of equivalence. We have commutation, association, external negation, internal negation, double negation, tautology, contraposition, predicate, distribution. And then there are simplification as rules of inference. And the last one is the major workhorse, which is the dictum de omni, where you look for a universal term, and it takes look at two M's. One is universal and the other one is not. And one is considered the donor. It copies everything that is not the universal shared middle term there. All the donor get plopped into the where the host is, and what you get is the conclusion, which is the original host with the new thing that was donated. And that's the idea of the inference, making two to come to a conclusion. So originally, as I said, math logic gives two different notations or two different forms of something that's similar. Like Socrates is a thinker, all men are thinkers. But it translates into two different notations. So that's why it's so difficult for people to to understand. But with plain logic, you almost have the same similar structure, S plus T. And the other one is every M is T. And that allows for a way to just transcribe what's spoken in English, in this case, and then just plop it into a notation that can be used to do logic with. So let's look at the proof that I asked us to at the beginning. Anyone obsessed with current trends is attracted to social media influencers. Every current trend is something based on K-pop music. So the conclusion is, to be proved, is anyone obsessed with something based on K-pop music is attracted to social media influencers. You remember that the other proof with mathematical logic requires 15 steps in total. How is this to be proved in plain logic? Well, first we have to translate them into the notation for doing so. And here it is. And you can see, you can read it closely. You can say, here's the universal every. Let me turn on the. So here is the every. And then the first term is obsessed with current trend. And here's the every S is P. So this is the predicate right here. The predicate has this recursive structure, which is attracted to social media influencers. So that's the premise one. Premise number two is every current trend is based on K-pop music. And then the conclusion to be proved is everything that you see here, and I'll read it, everything that is obsessed with something that is based on K-pop music is attracted to social media influencer. This last bit, by the way, didn't have to be exploded that way or analyzed this way, but because I had a longer thought, I wanted to demonstrate, but I don't have time for this. So I just kept it that way. So how do we prove this? Well, actually, if you can read the English sentence, you can already see how you can draw the conclusion. You don't need this, because this is such an easy example, but how do you do it? Well, it just takes one step. It's the dictum de omni, the DDO, as you saw before in this example. You find a universal middle term, and then you circle everything that is not the universal middle term, and you pop that into where that middle term is in the host premise, and you get your conclusion. And in this case, because I made the example, I made sure that it's easy. So there it is. You're able to see that there's T. T is the host, because it's positive, it's not universal, it's some, right? It's obsessed with some current trends. And here's the universal trend. Every M, this is the middle term, every trend is, and the predicate is this B plus K. So you just plop the B plus K where T is, and then there's your answer. And so you just copy it. So that's the conclusion. It's not that difficult in this case. But you can see that with the many rules of equivalence here, you can really have larger sentences and propositions that can be done. And so that's what I take the full thing of how to deduce from plain logic. And we can go on. I'm prepared for the example of the rhombus problem, what I call the dragon problem. What is the rhombus problem? That's the George Boole's problem of analyzing compound terms. The dragon problem deals with relationships, like John married Barbara kind of problems. The ant-bear problems is if A is greater than B and B is greater than C, therefore A is greater than C. That's what I call the ant-bear problems. But it's just ant-bear, beaver, chipmunks. That's A, B, and C. And reaching into multivariable, nested, multi-level clauses. And that uses, that's the specialty in math logic, to use multivariables in a function. And then the last one is more philosophical. It's about the prime mover problem. That is to infer the compound hypothetical sentences. I will stop here. That's for anyone who's interested. But my closing thought, I hope, is that every human being who joined the meeting today discovered that the world is open to reason by his using plain logic. And there's that sentence right there in this notational form. Yes?
Yeah, we're doing questions. So to what extent are these tools used in one on a chat bot with a large language model? Is there any kind of a treatment of the input language into the model using those terms, or the output, so that I don't get gibberish out?
No, I don't think there's any right now. This, as I said, the development of this started maybe in the 1980s and so on. Many researchers at the time brought these out, but it didn't get traction purely because of institutional inertia. There were a few textbooks that were there to teach people this form of logic, but it didn't catch on in college courses, and they continue to teach propositional logic and then predicate logic, but not in the regular language that can describe into notation. So no. Yes?
I like this whole methodology of thinking logically. Hopefully it's an adjunct to human logical reasoning. With that said, I have two concerns. You said you specialize in contradictions. I'm thinking the more complex the issue, obviously the greater the potential of contradiction. And then secondly, I guess in parallel to that number one item, I think this perhaps is the reason for AI hallucination, that there might be so many contradictions that it's perhaps impossible to include an entire set. Say one other thing, I'll listen to your response. An example of what I'm saying is within the future, perhaps, there will be automated driving. We won't be driving, we will be driven. I've also read that in the future, if and when this becomes a reality, there are still to be understood planned deaths on the road because of unforeseen events that were not pre-programmed or pre-calculated. In other words, contradictions that were not foreseen. So I'm concerned about this idea of contradictions being the solution because there are so many, quote, exceptions to the rule.
Well, thank you for the comments and the 2 points that you are making. My response is that ontologically in the world is what it is. And because the world is what it is, there isn't any ontological contradiction. So contradictions are our own mistakes that have been carried on in thoughts and carried through in culture, in books, in the media, and so the large language models that use that mass content to make their inferences, they contain contradictions because of that content. So it is the job of human beings to curate the input to make sure that nothing is contradictory, so that the model can then generate something that is more consistent with reality. The benchmark is always reality, and so that means that we have to do the curation to make sure that there's no contradiction in there. But that requires that the human beings know the language himself, to know that what is a contradictory sentence. Can we put the two sentences I mentioned there, determinism and free will, in the same paragraph and endorsing both? No. But a lot of people, if they don't see the sentences in English, but they see it in logical notation in math logic, maybe they just see, they're both there, compatible. So there's compatibilism and all sorts of things that can happen because they don't see the real connection in reality. So that's my solution. It's a long-term process to change the people to see that they need to make the language precise and then to curate the input. Thank you. Anyone else? Yes. Hi there, Don.
I wonder if you could comment on the fact that for more than 2 millennia, there's been the debate over what people mean when they say if A then B. In mathematics, if A then B means either A is false or B is true. But in ordinary language, if I hold up an egg and I say, if I drop this egg on the floor, it will break, people would say that's a true sentence. But now if I hold up a coin, a quarter, and I say, if I drop this quarter on the floor, it will break, most people will say that's a false sentence. But a mathematician would say that sentence was true if instead of dropping a quarter, I stuck it in my pocket.
Okay. If I can interpret your question, you're talking about material conditional.
Yeah.
And what this logical system that I'm talking about, plain logic, it doesn't recognize the math function involved in the truth table for the material condition. So that's the first thing that eliminates the problem. The problem of the paradox of the material condition that Don is talking about here is well known, and it is paradoxical, and it involves quite a lot in mathematical logic, but within the framework of plain logic and the logic of language, it's not there. And the same thing with the or function, because the if then and the or have that kind of equivalence, right? The equivalence rule called implication does exactly that. And that can be done without the truth function. And I didn't bring that in my lecture today, but there is a lot of work about that. And so to answer your question fully, the if-then structure is a clause. One is independent, the other one dependent. It's not two different sentences. Whereas in math logic, they are two different sentences having two different truth values, and then when you combine the two, you have another truth value. So actually there are three truth values being used. Whereas in in ordinary speech, as you suggested, there's just one sentence, one period at the end, but two clauses. And that distinction alone is how we escape the problem of the material condition. It's unsatisfactory, I know, but that's my answer for now. Anyone else? Yes.
It's my understanding that as they start developing like machine language for like learning, training, artificial intelligence kind of stuff, that they're going to get to a certain point where they're going to invent their own language, which would be kind of like tokens underlying the structure of our language. And when you start talking about logical constructs and you see a complex sentence and it depends on the starting and ending point and all that like stuff in between, at what point does it become, I don't know, problematic to where we don't really know what the language is, so how can the humans curate something that maybe might not have any, they might not understand how logic is being transcribed or transcripted or all of those terms. I mean, where is that? I guess I'm asking the difference between the essence of it and the carrier of it.
Okay. Thank you for the question. What I take the problem that you're raising is whose responsibility is it to take care of these large systems that will be service providers in the future, as the other gentleman talked about, automated driving and intelligent systems that can do things without human supervision, and they may invent their own language and their own manipulations behind the scene that we don't know about. And whose responsibility is that? And again, it's a human being. We are the ones in charge, and we should be the ones who should monitor those things. And that puts the onus on the human beings, the owners of such frameworks, to know what's going on. And that requires precision in language again. And it requires that the person is 100% sure of the thoughts that come out of his own head. Now, when you ask people, they have sentences, but the sentences that they bring out may be word salads, and they don't even know that. And that's a kind of a self-reflective kind of attitude that people have.
So it'd be more outcome-based? I mean, you say this is working or it's not?
It's not working because this is part of the culture.
Because you're creating responsibilities.
Yes,
And this is
and again,
or it works.
that requires people like you and people like me who are interested in, first, one's own thoughts, one's own way of grasping reality, to use language in a precise way, and then to get other people to appreciate the same. And then that may get them to the employees and employers of these organizations that will make sure that what they do follows certain precision to avoid contradictions and so on. And that gets to what Jamie was saying earlier about certain problems that are non-tractable or intractable. And it has to do with what I think is the primary case, that if you cannot articulate what you mean, this is Lewis Carroll's statement, that if you can't do it, then who's going to do it for you? And so it's the responsibility that if you say, oh, I know it, it's on the tip of my tongue, but if you can't articulate it, then you don't have the thought. So if you are the one who is the master of your own thought, and if you can't articulate it, then you don't have the thought. And if you can't articulate that thought, then how can you get other people, other employees to do the work or to get the message out? And
From
so,
your perspective, it's articulating the differences between contradictions.
yeah, and that's the problem with many people who don't know what it is that they are thinking, and so they will spout one thing, and then the next day they will spout the opposite thing, and they never know that they have already uttered a contradiction, because the precision of language is so important, and the foundation of plain logic is the word, not the whole sentence as unanalyzed. And so we have to respect that. That's my take. Yes?
So one of my immediate questions is, so I know nothing about this, but I've learned a whole lot. But Irish nuns taught me grammar using that thing you were showing at the front end. So that's grammar. but the grammar in English is totally different than the grammar in German. And so I guess my question is, these large language models, are they going to be just based on English? Is English going to become the permanent universal language? And so logically, there's also meaning. And so when you go to different cultures or different languages, how does that work out?
Okay, good question. Thank you. What Aristotle said on interpretation is that the human mind is one and the same. We are human beings, and so our thoughts are, as I said, are clothed in sentences. They're not without clothes, even in our minds. But the thoughts themselves are, let's say, similar or the same in all minds, all intellectual minds. And so it's just a different clothing. Some clothes requires a lot of stuff to be worn, but there's still the thought there. And so German may have a different syntax, a different way of organizing. Chinese, Mandarin, or any of the other languages, they all have different ways. But the thought, if we see the connection in human beings, it's the same. And so that is how we are able to read the thoughts of Aristotle and Plato and other people from thousands of years ago, because it's the thought that counts, not the language. So the large language models that you're talking about, where does it come from? It comes from the English literature or English texts, media and everything. But of course, English is the international language, and so that's the most amount of that is codified in databases and everything that has that's collected. But I'm sure there are German versions of saying smaller, perhaps, because not many people read German or print German. But I'm sure DeepSeek from China has its own Chinese version of the same, different grammatical rules, but I'm sure that they have that. But from the English version, they have language translators like DeepL. DeepL will translate sentences from one language to the other, and so it still works. So, but the point is, the large language model is based on probability of word connections to the next word. So that's more probability. It's not really about logic, but nevertheless, they're trying to be as logical as possible from there. And so that's my take on that. Yes.
Really quick, I've got one question here on the chat. Comment from Alvin again. In language, false premises can easily enter the conversation because of presumptions that are taken as underlying givens. So if you just want to make a comment on that.
Yeah, I agree. Alvin's comment is that it's our responsibility to know what's false and what's true. And when we introduce a false premise, of course, it will be valid in terms of deduction, but then it will not preserve truth. And that's the whole point of deduction. Yes, thank you, Alvin. Yes.
I'm finding personally, and I think this statement applies to all human beings regarding your work and the work of LLM and so forth, and that is, it's important to gather as much information as a human being can, or in your field, the clinicians gathering the data. With that hopeful, complete information, one can draw more accurate conclusions. Obviously, with we human beings, especially in today's divided world, we tend to draw conclusions based upon incomplete knowledge base. So I think we all can learn from your field, stupid. Take your time, do your homework, draw conclusions as the last step. Make sure you did your homework along the way.
Thank you very much for that point. I wanted to bring that out, but I didn't want to take it that far, but you're right. We need more induction in our lives. Deduction is satisfactory. As Alvin mentioned, you can introduce false premises and you can draw deductively certain conclusions that are not preserving of truth. But the point is, before you make conclusions, get more facts. get more evidence, and weigh the evidence based on larger principles and so on. That's the other area of logic that has been neglected because of the so-called problem of induction that many people thought about, but actually isn't a problem in Aristotle's theories. But anyway, thank you for that comment. Anyone else? Sir, what do you think? Yeah.
I didn't know enough to ask a good question.
Well, what do you think of the presentation then?
Say something reasonable.
Well, I just don't understand it, to tell you the truth. I had, in college, I had a logic class, and you know, it wasn't explained to me well enough, so I didn't quite understand it totally, and I'm sorry. You did a great job. You explained it well. It's just I just need some more closer understanding of it, I guess. I need some more. Yeah.
I appreciate your comment very much because it shows that adults in society realize that the logic that they were taught or not taught failed them to help them to think better, to help them to make better interaction with other human beings and to think well and to make decisions well for our lives. That's what logic is about.
Yeah.
And yet, somehow this past 20th century and now 21st century, the notion of math logic has caused people to be intimidated by logic and not to take logic seriously enough to learn about and how to think well with logic. Words like contradiction, words like contrary, contraposition, all these words, they're not technical words, but they're technical for logic, and yet people don't use them in everyday language. They don't use words like implication in the way that Don was talking about. So all of these are kind of an indictment against logic, math logic, that says that people, grown-ups, and young people are not versed in logic in such a way that they can use it in everyday thinking. That's a really bad indictment. What about you? What's your thought?
Well, I had a variety of thoughts, but one was a lot of your discussion talks about English grammar. And it reminds me that when I was in school, my teachers and others didn't know English grammar.
Mm-hmm.
I distinctly remember that because I tried to learn a foreign language later. And I made a comment to my family, and they said, well, that's because the teacher you had in the 6th grade told us that he didn't understand grammar.
Wow.
Yeah. So a lot of people grew up without a good foundation, I guess you could say.
Okay.
The other thing I was thinking of in the discussion was, and I'm not sure how it exactly related, but we talk about the meaning or the definition, how important the definitions are. But the definition for different cultures varies a lot. So I don't know where you brought what different cultural interpretations would have an effect on your discussion.
Okay. Thank you for the comment.
Yeah.
And first, I think you're right that judging by your look, you're much older than I am. And if you think that the education that you had didn't teach you grammar, English grammar, consider the people in my generation and the younger generation nowadays in public school. They don't have any, except when they have to learn a new language. Perhaps that's when they get a smattering of grammar. But this should be basic education.
It should be.
And yet it's not. And then logic too should be part of basic education, as I am trying to show today, and it is not. And so there's an endemic problem that is going on right now. So that's, your point is so well taken, and I appreciate that. The second part that you're making is that the way that you're trying to put the connection back to today and to everyday life, but it is, I don't know. We will just leave it at the point that currently the society, the way that we are living, different culture have different meanings, only because they don't see the connection down to reality. So, and there's only one reality. There's not multiple realities in the way that relevant logic or any other forms that try to talk about multivalent truths that are out there. No, there's just one reality. And so we can judge a certain society, how successful it is, a culture, how successful it is by how people live in those societies. And concepts, ideas matter, words matter, and if they mischaracterize or make a wrong definition, in the long run they will suffer the consequence. So that's all I can say in a historical kind of perspective. But yes, concepts do matter, and we have to define them correctly.
I find myself spending a lot of time looking up the original root of a word. And it's just, that to me is an educational process.
Yes.
And how do you pick a word to use today in modern society when you really think that it should be something that was said way back at its root?
Yes. Yeah, good point. Thank you very much. Yes.
Yesterday, I was actually using AI, and a word came up, mnemonics, or mimicry, and so I asked AI about it. But anyway, the philosophy or understanding is that most humans learn by mimicry rather than by substitute. So going back to your thing about K-pop, so they all learn K-pop because they're mimicking each other as opposed to thinking in abstractions and puzzling through problems. Or you could also call it a memory issue, that some students memorize something without actually understanding it.
Good point. Thank you very much. Yeah, I think that part of not a problem, but a successful culture, a successful country makes it easy for people to coast. They don't have to do the work because they can just copy what's already successful. So the Monday through Friday lifestyle is, as an example, of a successful habit that people can adopt in a modern society like today. So that we work on Monday through Friday, and then we have fun Saturday and Sunday, and so that's the attitude. And so we can see all kinds of habits like that in the culture of a successful one. And so many people then don't see that there's a need to think about, well, should I follow the Monday through Friday model? Should I do something else? Should I have a different lifestyle for myself? And so it requires thinking. But because a culture is successful, this is a good model to follow. So why not just keep up with the Joneses? If they're successful, just copy that, and you'll be successful. If they have a new car, get another car because you want to keep up with them, things like that. So that's great. But then, of course, if you live in a bad neighborhood or bad area, you don't want to copy those people, I don't know, I hope. But again, people don't know that, so they may copy, again, as you suggested, yeah.
Thank you, Tom. We're way over time.
Oh, we're way over time. Okay, if you have any more questions, you can always talk to me